recording. Hopefully it's gonna pick up sound. My computer kind of sucks. We'll see. Anyway. All right, today, the most important class day of the semester. Ooh, we are gonna talk about the table saw. How it works, why it works, how to use it safely, all of those things. We touched a little bit on this last time. Not last class specifically, but sort of as we've been talking about using all of the machines, that the table saw is the tool that then finishes out the whole dimensioning process, right? You've got thickness being established with the joiner and the planer. You get a 90-degree side on one edge. Then from there, table saw is going to cut a parallel side to that one, and then last but not least, we're going to do the length. That's the order that you need to remember things in, right? I did this last time. You go thickness to width to length. In that order. The reason for that is because we're going to have a reference side that we're going to need, that we get when we're doing our milling initially. Ostensibly, when you are using the table saw, you're cutting a parallel surface to that, but that is not always the case. Operator error and or the sharpness of the blade will sometimes make that cut a little bit bowed, and I'll show you how that happens. But knowing what our reference side is, you know, that helps us to establish our length. It's just easier. It's easier and better to cut everything to width before you cut it to length. Length is always the very last thing you do. Gotta think for a second here. I'm still waking up. Hello, morning coffee. What's going on? Hi. Delicious. There we go. So, table saw. Yay. There's some really big general rules about everything that you do on the table saw. Rule number one, you never cut anything that isn't milled. You have to have dead flat reference surfaces on that saw. It's not like the bandsaw where you can kind of, you know, move things around a little bit. If there's a little bit of a bow, you can kind of negate it. The wood must always be milled. Only milled lumber. So nothing without a flat reference on both the bottom and the side. And that doesn't mean flat-ish, that means flat. So if you're looking at it and you're like, well, this board's mostly okay, it doesn't really have anything going on. This isn't a contractor saw. This is what's referred to as a cabinet saw. The motors are 5 horsepower each. They can chuck a board across the room like you would not believe. You have to make sure that when I say flat, I mean flat, not like flat-esque. So having a properly milled board becomes extra important at this point. Remember how we talked about 2 millings? Yes? There's a reason for that. Those 2 millings allow that board to step down in flatness, you know, and be less inclined to move on you. So you have to have your milling completely done before you do this. That thicknessing has to be done, right? Again, that's part of the reason that we're doing it in this order. So thickness, both millings need to be completed. 2 millings done. Likewise, when I was talking about, you remember this guy right here? Subdivide your lumber into its smallest millable parts before beginning. Same idea, when we go to cut things apart on the table saw, and if you've got something really big and you're subdividing it into lots of really small things, that can be problematic as well because it's going to want to bow and move and potentially pinch the blade. The biggest hazard with the table saw is not cutting yourself, believe it or not. The biggest hazard is something called kickback, which, I mean, I think all of you are familiar with the concept of kickback, but what that is when your wood gets stuck somehow between the blade and the fence, or the blade and the blade, or something, puts pressure on the blade, catches, and pushes back at you. Generally speaking, when that happens, it's not a little comfortable, what's going on? It's a, I'm gonna chuck this thing back at you at 90 miles an hour kind of thing. So, when I show you how to be using the machines today, it's for, the two safety considerations are to keep you from getting cut, but also to avoid kickback. Avoiding kickback is huge, because that's really where people tend to get injured. You know, sometimes it just involves a big old bruise on your hip, but why would you want to do that in the first place? Depending on how tall you are, you can endanger your bits. It's a bad thing. Don't endanger your bits. That's quote of the day. All right. Rules, dead flat. Okay, there's two kinds of cuts. We talked very briefly about this as well, but now is the time to record it and to like set it to memory. There is the rip cut and the cross cut. Only the lumber danger in kickback and cutting injuries. I don't want to minimize the possibility of cutting injuries, but we do have a saw stop, which is the one that senses flesh. People call them the hot dog saw. The likelihood of getting cut on that machine is extremely low, but kickback is still just as high as it is on any other machine. Not to mention the fact that table saw injuries tend to be pretty easily repaired if you do happen to cut yourself. That sounds really horrible, but comparatively speaking, there are other injuries that can happen in the wood shop that are much, much more devastating. She says casually as she drinks her coffee. Yeah. Anyway, rip cuts. Rip cuts happen along the length of the board. Generally speaking, parallel to that side that you have run on the joiner to make 90 degrees. You'll notice that I said along the length of the board. I didn't say with the grain. This is a physics issue. By and large, the length of the board is going to be with the grain, but there's always going to be an exception. Mostly that exception is going to be plywood, right? Plywood doesn't actually have a set grain direction, each lamination being 90 degrees from the previous one, right? So this is a question of dimension then. That's why I'm talking about it in these terms. The length of whatever it is you're cutting versus the width of whatever it is that you're cutting. Rip cutting is along the length. For all intents and purposes, this is going to mean with the grain when we're talking about solid wood. But, you know, just be aware that there are the occasional little bit of exceptions because it's woodworking, and of course there's exceptions. That's just how that goes. Rip cutting is, of course, the one that you're going to do to establish width. So, again, by and large, you're going to go to your rip cuts first. You're going to get those widths established before you go ahead and, you know, establish your length. Rip cutting, check it and see. Terrible. Rip cutting blades, and I'll show you when we get into the machine room. Rip cutting blades are, they have evenly spaced teeth all the way around, looks like a wave pattern, and there are not very many of them. There's something like maybe 40 to 60 teeth on the entire blade. I'll show you, but it has this kind of a blade pattern, like a series of sharks. Cross-cutting, of course, happens when you are cutting across the dimension of your board. And because cross-cutting is typically across the grain, the blade that we use for this similarly has evenly spaced teeth, but it has many, many more of them. Because it's taking tiny little cuts. It's digging through and being like, I'm gonna tear across the wood. You know, it's creating more debris like that. The rip cutting blade is almost like trying to ask the fibers to move aside. You know, it's like, hey, we're going this way. And the board's like, yeah, okay, because that's how it grows in the first place. You don't need to have as many teeth. So having the right blade on the table saw is a fairly important thing to do. Nice thing about this is that I have 2 table saws. Well, I have 4 table saws, but I have one table saw that is almost always exclusively set up for ripping, and one that's almost always exclusively set up for cross-cutting. So instead of having to change blades or worry about any of that, you're going to come to the one to do your rip cuts, and you're going to go to the other one to do your cross cuts. It's a miracle. In order to make controlled cuts here, another one of the rules of the table saw, you never freehand, ever. There is always some kind of supporting guide that is helping you. So, in the case of a rip cut, that is this little dude right here. It's called the rip fence. Again, you'll see it when we get to it. Rip fence. What this is a movable, jig that sets up a perfectly parallel cut to your blade at set distances. So you can move that fence, lock it down, check your ruler to see what it is, and if you need a board that's 10 inches wide, you set it at 10, you make your cut, and the board that you get is 10 inches wide. It's a beautiful, beautiful thing. For cross-cutting, there are other kinds of jigging that you're going to use. You're either going to use what's called a miter gauge, which slides in those slots that you see on the metal beds of the machines, right? You guys know what I'm talking about? The little channels that are in everything? That's to accommodate a miter gauge or some other kind of guide. But what that does is it lets you hold onto your board and push it through past the blade in a controlled way. Make sense? We also have sleds, and the nice thing about the table saw that I've got set up to do cross-cutting is that I have a sled for that. The benefit of that is that the entire thing moves. Instead of just this thing that kind of lets you push just the board past, the whole sled moves past the blade. It keeps the board from wanting to slide side to side as a result of friction. So that's not a bad thing, it's an extra good thing. One of the big rules here, you never combine methods. So if you use one or the other, you don't use both. So if I am trying to cross-cut, but I need it to be a specific length, I sure as shit don't put my rip fence over here and say, well, if this is how long I need it, I'm just going to butt it up against this and then go. Because what I end up with is a board here that's trapped between the blade and the fence. And what happens to that board? It goes flying back. It probably climbs the blade and ends up with a big old, half circular cut mark in the middle of it. I've seen it. The boards go. It's incredible. So if you're ripping, you're just using the rip fence. If you're cross-cutting, you're just using a cross-cutting mechanism. I realize that it seems like it would be smart to use the rip fence since when you set it up to a certain point, it's that set length. And you can actually use it as long as you use some kind of removable piece in between. Like if I have a piece of wood that I know is exactly 3/4 of an inch thick, for example, I could set my fence to 20 3/4 or whatever I'm trying to cut that to, put that little block in there, move my piece up to it, and then take that block away so that when it cuts off, it doesn't get twisted and bound between those things. Likewise, if I have a huge, let's say I'm making the top of a coffee table, right? Coffee table top, pretty big. I've got my one short end over here, I got my long end over here, and I'm like, okay, I want it to be this long. And I take it to the table saw, and I try using the rip fence, the entire tabletop is gonna shift like this. And it's gonna cut a giant arc in the end of it. So, major rule, rip fence for rip cutting only. Some kind of cross-cutting mechanism for cross-cutting, sled or miter gauge. We'll get to it. All right, let me see. Thickness with length, lumber. Oh, aha. The most dangerous situation that catches people unawares is when you're cutting a square. We've talked a little bit about this on other machines, but on the table saw it's hugely important. As soon as the board that you are cutting is starting to have its length and its width close to the same dimension, that is going to become a frisbee about as fast as anything can be. Just take off across the room. Especially if you're trying to rip cut. something like that. Because you're trying to keep that side against the fence as your reference, and physics doesn't want that to happen. It's really easy for that piece to twist without even trying, and for it to just go again. I've seen it so many times. One student I had once made a box with that piece in the lid because it was just so like perfectly mangled cut that was in there. She was like, I don't know why I did that. And I'm like, hold up your piece. And she did. And I'm like, oh, it's a perfect square. That's why. Be aware. That's a thing. So, anyway, probably what will be not much of an issue for anybody for this assignment. We're going to be mostly working with extremely long and thin pieces, but regardless. Coolio? Everybody got that? Okay, well, we are going to go in the machine room. If you want to take your stools, that's fine. I'm going to specifically array you around the table saw so that you can all see and not get injured. So. I bet. All right, table saw. Let's talk about the parts of the table saw here, because these are important things. Anyone want to guess what the big metal part is called? Anybody? What? Good guess, but it's the bed. It's the bed, just the same way that it's the bed of the joiner and the bed of the bandsaw and whatever. This little guy right here is the bed, right? These slots that you can see on either side that I was talking about, these are the miter slots, M-I-T-E-R. Miter. Like always with these guys, there is a throat plate. There is a small, or comparatively small piece of wood that fits in here and is replaceable. So we can cut into it if necessary. But it also keeps you from, your wood from slipping down in there. This one is what's referred to as a zero tolerance throat plate, meaning that when I bought it, it was a solid piece of wood. And we cut into it very specifically so that there would be as little room on either side of the blade as possible. I am, however, going to change this throat plate out for a different one to accommodate another accessory. This one. This throat plate, you'll notice, has a slit that goes all the way through it. This is the one that came with the machine, or the style at least that came with the machine. I don't know if it's the actual one. But this accommodates this, which I'll show you in just a second. The controls for this machine are on the front. Because this is a flesh sensing mechanism, it has two controls on it. It has an on-off switch that is yellow in the front. That turns the entire machine on. If you don't have that on, you're not going to be able to turn on the machine at all. So if the light here is green, it means that the machine is ready to go. Right there. The crank is also to control the blade height. So you have to have the yellow switch turned to the on position. This is not going to start the blade, though. This is only going to prep the entire system to be usable, right? Because it has a little sensor in it. It's running current through the blade right now as a kind of ohm meter, and when it detects the wrong moisture content, that's it. That's when it goes kunk. Let me tell you, check it out, watch. See that? So when I put my fingers on the blade, a little red light started flashing, saying, no, it has the wrong moisture content. It's not going to, and it won't turn on. I wouldn't try it, but I'm not stupid. But I know that it's working, and that's a really good thing. So that's another rule about this specific table saw. You really can't cut lumber on here that is in any way, shape, or form wet. So if it's found material that's come in from the outside, if its moisture content's too high, it's going to set the breaker. And when that happens, it also ruins the blade. The blade is toast at that point. And we send the breaker and the blade back to SawStop, and they run a code off of thing for science. Anyway. So as much fun as it seems like it would be to just set off a breaker and be like, ooh, neat, the blade disappeared. Please don't. If you do, intentionally or carelessly, it goes on your art cache. You get charged for a new brake and a new blade, which all together runs about 150 bucks. So just be prepared. Like, now if you set it off accidentally, that's what it's for. And I'm not going to charge you for that. I will eat that. But anyone being careless, that's when I start to, give out fines, as it were. It's sort of a fine, right? Fine for foolishness. So anyway, this machine, the blade is controlled by this crank in the front. There's a crank in the front. There's also a crank on the side. Most of the machines that are in here, you're going to see the same thing. The locations of the cranks might change, but the one on the front controls blade height. The one on the side controls blade angle. So the nice thing about this is that I can also make an angled parallel cut. It's a beautiful thing. Make an angled parallel cut. Hot damn. Most new table saws have what's referred to as a left tilting arbor, meaning that the blade, when you raise it, if you change the angle, it's going to move to the left. Older machines have a right tilting arbor. For example, the cross-cutting saw on the end there. That one goes like that. The danger with that is that as you're cutting, that piece that you're cutting is getting pinched between the blade and the fence. And the likelihood of kickback is much higher. Naturally, of course. That's why most newer machines, it's got this kind of thing going on for it, so that as you're rip cutting, it's just a safer proposition. Anyway, I'm going to raise the blade on this guy. You do that by loosening the knob in the middle, much like you're doing on the planer, and then turn the crank. All right, so that is the blade at its highest point, right there. It's something like 3.5 inches up. It's not a huge amount. Table saw blades on average are, and that is a cross-cutting blade. No, wait, no, that's a rip-cutting blade. What am I saying? Table saw blades on average are, go ahead and put it on the floor, it's okay. Are 10 inches in diameter with a 1/2 inch hole in the middle. That's what's referred to as the arbor. So there's the motor, and then this little axis that comes powered off of that, that's the arbor. And then the blade itself. This table saw, this monstrosity over here, that mostly gets used as a table to write on or to do other things, is a 12-inch table saw. Its blades are huge. It frightens me, even me. This saw is just like, whoa, yeah. So generally speaking, we only use this saw for cross-cutting. And we do it for cross-cutting with that giant sled right there. So this guy gets mostly just used for plywood, ultimately. You're going to use this one and that one. This table saw, if I move my seriously still in progress piece here, this has what's referred to as a stacked dado head in it. So it's not one blade, it's, in this case, 4. See that? That lets you take passes with a huge, wide path. It's great for joinery, lots of other, special, sort of woodworking specific things. But we never take the stack dado out of this. We just change its size, pretty much. But that's the luxury of having 4 table saws. We can really sort of say, this is for this one, this is for this one, etc. It can be turned back into a regular table saw. That'll just make a rip cut or whatever. But because we have the saw stop and it has those safety mechanisms in place where you're not going to cut yourself, I would recommend using it. So, and if you have questions at any point, please just pipe up. So this little dude right here, this is referred to as a riving knife, R-I-V-I-N-G. When I spell it, you write it. Again, there should be like maniacal note-taking happening here. The riving knife is sometimes referred to also as a splitter. In this case, this is specifically a riving knife because it looks like a shark fin and it doesn't have little hold downs on either side. Splitters frequently do. This one also comes up over the top, which splitters won't. Splitters will just be this little thing that sticks up out the back. The purpose of this tool right here is to help keep your board from pinching the blade. As you are making your cut, the riving knife helps to keep tension off the back of the board, which is going to minimize kickback pretty dramatically. If you don't have the riving knife on this machine, it should be for a reason. And I don't know what that reason would be right now. Sometimes when you're making an angled cut, you need to take it off. But like, by and large, anything that you guys are going to be doing on this, you should have the riving knife on there. So, anyway, the way that it is taken on and off, and you might want to cycle through to see this, is there's a lever in the back here. Lever. When I lift the lever, I can pull this out. I can put it back in, tighten it back down. There it is. There's also a plastic door inside here that I can open and close to help make room for my hands and things. I wanted to show you though how to change the blade in case you needed to do that for whatever reason. So, changing the blade. Take notes in a step-by-step process here. You're going to begin by raising the blade to its highest point. In the case of this machine, I am just going to turn off the power here at the box. Otherwise, turn off your power. That probably should be step one in place of raise the blade to its highest point. Step one, turn off the power. In the case of every other table saw in here, that's going to be done at the breaker box. You find the breaker that controls your saw, you turn it off, you double check that power is actually off to that machine. You do that, of course, by turning it on. And then you're good to go. Raise the blade to its highest point. In this case, then you're also going to remove the riving knife so that it's out of the way. On the saw stop, there are two large identical wrenches that are located on a hook on the left-hand side. Here they are. Every other machine in here also has their tools kind of labeled and closely located. In the case of the one right behind me, they're on the sheet on the back. The one closest to the door there, they're on the front there. You need to make sure that you're using the proper wrenches and that you put them back when you're done. But you'll notice that these guys are angled. Yes, there's an open end and a closed end. You take the open end and you put it on the arbor side, angled away. Closed end on the nut, angled away. So look, now my hands aren't going to hit one another. It's a beautiful thing, this small bit of engineering that they've done. And then, in theory, you just pull on the one side. The thing about arbor nuts on table saws is that they are threaded in reverse. So this is not righty-tighty, lefty-loosey, this is lefty-tighty. Because otherwise, as you were cutting, this would loosen. Instead, what's happening is that as you're cutting, this tightens up. So, there is the nut. There is a stabilizing washer. This will be on all machines. Stabilizing washer. And then lastly, the blade. Do not set your blade down on anything metal or anything where the teeth could chip. The teeth themselves are made of carbide, which is extremely brittle. It's very, very easy to damage a blade like this. If you drop it on the concrete, it's toast. So The tops of your fence are going to probably be rubberized just a little bit. You can set it down like that, not a big deal. Or, you know, get yourself a piece of wood, set it on top of that. It's just fine. This blade itself is still sharp, but it's a little dirty. If you do need to clean a blade, and you can, if you want to like clean the blade and go ahead and put it back on the machine, we do this with oven cleaner. It's really pretty straightforward. I've got a can of Easy Off in the back corner there. You shake it up, spray it around the sides, both sides, down the middle, let it sit for a minute or two. Scrub it off with a wire brush, rinse it, and then you are going to use the compressed air to dry this completely. Because remember, a wet blade in here is going to set off the brake too. Does everyone know how to turn the air compressor on? Or access the compressed air? Okay. Perhaps you're going to be in charge of making sure that this is visible too. Yes. You might actually have to move. So over here, lovelies, there is a orange handle with a pipe there, right? Pipe goes across. With any kind of pipe that moves gas or liquid, if the lever is across perpendicular to it, that means it's off. When it's parallel to it, it's on. This is going to be true in plumbing, gas lines, in this case compressed air. I have the air hose right here. And generally speaking, the little like air compressor like administrator thing, that's a really technical term, is either going to be in here already or sitting right there. The way that you change the head on this is you pull back on this collar, and on this end here that has the change in diameter, some people like to try to put this end in. It's this one. Pull back, put that in, let it go. There it is. Once you've got it in, then, do you hear that? Lovely. Excellent for blowing sawdust out of your clothes. Don't use it on your, near your ears though. You can actually damage your eardrums. But, make sure you turn it off again when you're done. So if you're ever trying to dry something metal, the way to do it is to blow it off with compressed air until it's completely dry. And you'll notice also that there are these little there are all these little cuts, fine cuts in the blade. Water will get trapped in there, so you have to make sure that you really, really have it good and dry. Okay, anyway, putting the blade back on. Make sure that the blades themselves, or that the teeth are facing towards you. Remember, the saw is running this way, over the top towards you. So if you don't have the blades coming that way, or the teeth coming that way, it's going to be a problem. But you go ahead and slide it on the arbor. Put your washer on. Just having a quick look at my stuff here. Anytime you see something that might have some rust, you can do a tiny little bit of maintenance. Or tell your mom here, and she'll take care of it. I am in a constant battle against rust in this shop, so, you know, I won't be too surprised by it.
What lubrication do you want to put on it?
WD-40. WD-40. And if you can't find that, 3-in-1. One of the two. Anyway, then you're going to go ahead and put your nut back on. If for whatever reason you drop it, either one of these things, that's fine. I can get in here and get them out. But do not just like walk away and leave stuff. It's a terrible idea. People do it occasionally. Then you put the wrenches back on, just the way they were before, and just very loose. You don't have to crank the crap out of it. Like I said, it's going to tighten as it runs. So just make sure that it's on there. That's really all there is to it. There we go. And then before you put the throat plate back on, lower the blade. Don't try to put the throat plate on or take it off if the blade is up. It's just not a very nice thing to do. Additionally, the throat plate for this table saw is different than the ones for the others in that the back end of it actually locks in. This one, if I were to, I can just lift it. You can see it's just a piece of plywood that's a shape. This one's not like that. You have to like lock the end in underneath. Do you see these little knobs here? These little screws? They lock under these that are in the inside of the mouth here. So under that, drop it down, push the little silver guy in. And then check, is it flat? If it's not, if it's sticking up, this one is so well fitted. If it's like this, people don't even notice sometimes that it's sticking up because it's such a small amount. But double check if you're gonna take out your throat plate. People tend to want to smack on it and then they get busted and then I gotta buy new ones, which isn't great. Changing the angle of the blade. I'm gonna just raise this enough that you can see it. But like I said before, there's gonna always be the control on the front, which is the blade height, and then the control on the side, which is the blade angle, right? So, in order to change the blade angle, same idea, you loosen that middle knob. There you go. And then that is going to allow you to begin to change the angle of the blade. So not every throat plate can accommodate angles. It's one of the reasons why we trade out between them. This one, for example, I've hit its limit already. So be aware that you are going to want to change things around. If you are going to set an angle to something other than 90, am I going back up? Yeah. You should always raise the blade to its highest point in order to establish an angle. The reason being that if something is out by 1/4 of a degree, you're not going to be able to tell if there's only this much blade up there. But any kind of discrepancy gets exacerbated the longer the length you have to compare, right? So raise the blade to its highest point before you establish an angle. All right, the other thing I'm going to do now, because I did change that, is I'm going to double check that it's 90 degrees again. Dear God, this is really important. Most of the machines on here, you've noticed, have what's referred to as a positive stop, meaning that ostensibly when you set it back to its 0 point, it's set at 90 degrees. The positive stops on these things generally have play in them for the reason that they need to be adjustable. Sorry, this is just being a little, I'm gonna break my own rule here. Woo. So, for example, where it's set here, I don't actually think that this is exactly 90 degrees anymore. And I say that based on experience more than anything else. So, you can do one of two things. You can either leave the throat plate in as long as it's a little bit below the surface, or take the throat plate out, take something that you know is parallel, in this case, plywood. Plywood is the result of a machined process. So I can set that right there and get my combination square or my engineer square very close to the blade without having to worry about deflection. I'm going to grab my combination square. That's all right, that gave me the opportunity to grab my goggles. At least it was in there. I'm going to grab an engineer square. The thing is that your combo squares, my darlings, are probably not probably not as accurate as the Starrett's, right? This is one of the $100 ones. Even the engineer square is going to probably be a lot more accurate because it's, you know, welded in place. It's not something that's adjustable. So either use a Starrett or use that kind of square right there. And you want to make sure that you move it up to the blade where there's no carbide tooth. So you're looking at the face of the blade itself, right? And then from there, I can see already, even on that small amount, where it isn't quite at 90. And I can move this back and forth until I get whatever is the closest thing to it, which I believe is going to be right there. Once I get it, I lock it in place. Okay, so there's that. All right, so a couple more things about the anatomy of the table saw, and then we'll get to cutting. This beautiful bad boy right here, this is our ripping fence, right? This is what's referred to as a Biesmeyer style fence. You don't need to know that, but you know. The idea is that there is a handle on the back side, these two wings on either side, and the handle has a cam lock attached to it. So as we set this in here and move it back and forth, as I push down on the handle, that puts pressure on the cam lock, and now this can't go anywhere. See that? I move it simply by lifting the handle, moving it over, locking it down again. There are two different sort of measurement indicators on here. There's one on the right-hand side and there's one on the left-hand side. That's these little plastic dudes with the red line down the middle, right? Those correspond with the tape measure on the left-hand side of the blade and the one on the right-hand side of the blade. Surprise, surprise. So if I want to cut a board that is 8 inches wide, what I'm going to do is I'm going to lift my handle, move the fence to that 8-inch mark, and then lock it down. One of the things about this, though, is that because this isn't like on a track or anything, it has a lot of movement this way and this way, right? When I go to lock it down, sometimes it moves. And so right at the moment, this is at 7 63/64, which, believe it or not, is a problem. That's not 8 inches. That's less than that. We are entering the phase of woodworking where accuracy really matters. So in order to make a micro adjustment, this is important. I want you to loosen the handle, and you're going to give it little tiny baby spanks. Seriously, this is how you micro adjust. Tiny taps. And I mean like tiny. And it just means you're going to do it, you know, probably more times than you think you need to get it to where you need it to be. But like, that's the best way to do it. And don't try to adjust it out here. You're adjusting it here, right at the head. So what I'll do is I'll get it close. Let's say I'm going back to that 8. I get it as close as I can. I lock it down, and then I loosen it again. Locking it down gets it like back in line to where it needs to be. I loosen it. I make my micro adjustment. And I want you guys to be as accurate as you can with this. And then lock it down. One of the things that I'm going to be checking you out for when you do your individual table saw checkout is how accurate your cuts are when you're making your width adjustments. And I'm able to tell that based on the thickness of your cutoff. Like, are your cutoffs consistent? Well, that means you're moving you're moving your fence consistently. Make sense? Yeah? All right, so, got that, I got this, I know how I need to set it. Now I just need some wood. I got a quick mill, a tiny little thing. It's gonna take me not very long, but this is the time to use the bathroom. So, we're gonna hit pause. All right, so, thank you for waiting for me while I did that. Now, of course, normally you would have milled your board twice. I, being who I am, did not get to it yesterday, and therefore picked the flattest board that we have, which is beech. Beech just doesn't want to move hardly at all, regardless of cut. It's one of the reasons why it's one of the industry's darlings when it comes to furniture making. That and its ability to take on the appearance of many other different woods when you put stain on it. It's not a bad thing. Anyway, so I have this piece of beech that I have milled down to, what did I mill it to? 7/8. And I made sure that I have a 90-degree side right here. This is so important. This is my 90-degree side. You thought that was important before? Guess what? It's even more important now. What I'm gonna do on this side that I ran on the joiner, and I made all pretty, remember too to do that one pass nice and slow. The more you eliminate work later, especially now, is going to be really important for you. So I've got this one nice, slow, 90-degree joined edge, and I am going to, with my pencil, I just wrote ref on it because this is my reference surface. This is the one that I know is 90, this is the one that I know is flat. How do I know it's flat? Well, I can put it on the bed of the table saw here, or the bed of the joiner, or any machined metal surface, and I can look for a gap anywhere, and there isn't one. That's dead flat. The key to getting a dead flat side like that when you're doing your milling, incidentally, is as you're joining, to shift your weight to the far side of the bed as you're going. So when you're starting, let's pretend that this is my cutter head right here. I'm going through, I have my pressure back here, trying to keep the back bed as my reference, right? That's the infeed side, or I'm trying to keep it this way. As I go across, I'm gonna shift my weight to that outfeed side. Because frequently what happens is when you're going in, if you keep all of your body pressure on the front, as you go across, it takes a little chunk right out of the back. I think some of you guys have noticed that, where there's just this little sort of scoop that happens right at the end. The way to avoid that is to switch your downward pressure, if there is any, to the outfeed side before you get to that point. Pretty much as soon as you've got more than half of the board on there, you can do that. Okay? So just for what that's worth, getting that side dead flat is super important. All right, so I've got it dead flat. I've got it labeled. Since I have two milled sides, either side can run on the bed here. You can, believe it or not, go ahead and cut a board on the table saw with just one joined side and one joined edge, and the top being whatever. You just can't use it on that reference surface. Regardless, generally speaking, that's not the way we do it. We do it like this. Anyway, so the first thing you're going to do is you're going to set your blade height. You have to make sure that your blade is at the correct height for what you need. I'm going to turn my saw back on, let it initialize. The saw will be ready to go when there is a solid green light on. If for whatever reason you're getting a different light code on here, like right now the red light is blinking intermittently, all that means is that it's initializing. And now the light is just solid green, it's all good. There are codes on here for what is wrong. You'll just have to come down and take a look right on the side of the control box. There are, this is what this blinking code means. And until you correct for it, it won't turn on. So anyway, I've initialized, I'm all good. You are going to want to raise your blade so that the height is about 8 millimeters or so above the top surface. What this equates to is just past the carbide, but not past the gullet. meaning that you're gonna have one of the little toothy bits sticking up, but you're not gonna have it up so high that the space between the teeth is above there as well. Does that make sense to everybody? You want the gullet to be below. So right there, that's probably even a little high for me. That's good right there. Yeah, not quite a centimeter above. Once you have your height established, lock up that center wheel, of course. And then the most important things to remember when you're making your cuts is that you are going to hold the board down to the bed, tight against the bed. You're going to hold the board tight against the fence, and you are going to push your board all the way past the blade. Down to the bed, tight to the fence, past the blade. Remember what I was saying, that the big danger comes when the blade catches something and pushes it back at you, right? So if, for example, as I'm making my cut, I don't push it all the way past the blade, right here, in theory, the blade can catch this and just send it shooting back at me. It's not a good thing. I don't want to do that. So what's the appropriate body positioning for all of this? With this saw, the really cool thing about it is that its off switch is a hands-free thing. It's a beautiful, beautiful thing. At some point, I want you all to come around to the front here and take a look. This on-off is a giant red paddle. You pull it out to turn the saw on, you push it back in to turn the saw off. So, observe. So it's engineered that you have to really put some work in, not work, but you can't turn it on by accident. Like that would be a really incredible feat of opposable knees for you to be able to turn the saw on by accident. But you can turn it off by accident real easy because this is a very sensitive switch here. Like you brush against it a little too hard, boom, it turns off. It's an amazing and excellent safety feature. I have been looking for and not been able to find essentially aftermarket switches that will convert the rest of these to something similar. They used to make them. I don't know why they stopped. I don't know. But regardless, it's a paddle, whatever. So when you are getting your body set for the table saw here, what I want you to do is stand to the left of the blade. Like usual with just about everything else in here, you're going to stand to the left of the blade. Do not stand directly behind the blade. Think about it like this. If my board were to kick back at me right now, boom, right in the ovaries. Terrible. Goodbye, generations of little Martins, never to be seen. If you're a boy and you're even taller, oh dear, you're going to have some issues. Do not stand directly behind the blade. Stand to the left of it. If it helps you to think about it in this fashion, you want your board to slide past you the same way that it would if you were playing pool and you had the cue, coming right past your body. It's really, really similar location, right on your hip, close by, but not in the line of fire, right? You're playing pool with it. That's what you're doing. So I usually begin by getting way up on it. Like I stand square to the fence. I've got my leg on the switch at the moment. I'm resting my hips on here. I take a step back with my right foot. I haven't moved my left foot at all yet, but you see I'm moving my entire body back. So I'm not touching the switch anymore. I'm just sitting there. That's going to let me then turn my body a little bit more and come forward again so that if I extend my knee forward, I can hit the switch, but that I'm not on it right at the moment. That's the one thing that happens frequently when people are first learning this machine is they lean forward enough that they turn it off mid-cut. all the time. All the time that happens. So anyway, right up front, I'm in the right spot, I back it up, and then I can kind of turn my body, and that lets me move over so that I'm not reaching. I don't want to be way over here. Similarly to the joiner, I want to be facing in the opposite direction to how the machine is pushing me back, right? This is pushing this way, I'm pushing that way. So, don't want to be over here. I want to be here, but I just don't want to be in its path. So here I am, slightly turned, and then there it is. My left hand is the helper hand. It's not the one that's doing most of the work. It's helping. The right hand, or, well, sorry, Damien, it would still be the right hand. This is a right-handed process. The right hand is the one that's doing all of the work. Its responsibility is to push the board all the way past the blade and to keep it tight to the fence. Believe it or not, the left hand just helps with that. I will, as I'm feeding this through, put a weird kind of twist on my board to keep this tight the entire way through. So what that looks like is I'm pulling backwards with my pinky finger and I'm pushing forwards with my thumb. I'm not twisting. I'm like trying to rack the sides, if that makes sense. Because how do I keep it tight right there? Well, I have to put some really kind of strange pressure on it to get it to do that. The thing that happens, remember how I said that the cuts that you get are not always actually straight, that sometimes they curve? The way that that happens is when the back end of the board starts to travel away from the fence. So if I'm going through this and friction from the board starts slowing down this side, slowly but surely, I get a gap at the back. And when it comes out, what I have is a board with a big dip in the middle. So everyone will think that they're doing okay. They'll be going through and be like, no, it's fine, because they still have the front tight to the fence. But if you don't have the back tight to the fence too, I'm gonna move this over and see if I can actually get it to do it. Come on, baby. It might. Watch. It might do this, it might not. Nope. Gotta make it a little smaller. But as I go through, that's too tight. Whatever, it'll do it, is my point. It will do it, it'll be a thing. It takes practice, and it takes monitoring to get it to not do that. Most people are going to end up cutting with that dip in the first place. It's just what happens. But that's why we have this reference side labeled. Frequently, as you're going, you can rip cut and do, make one side that's not perfectly whatever, but it's okay as long as you have one side that's dead flat, because that's the one that we can use then to establish our square offcuts. So, anyway, so what does my left hand do? My left hand is my helper hand. I always start with my board in front of the blade, nowhere near touching the blade, of course. And you'll notice, some of you can see it, some of you can't. There is a mark on the fence here that indicates exactly where the front of the throat plate is. So that even if in your cut it's completely covered over and you can't see where it is, there's this mark right here that says that is as far as you want your hand to go forward. Because my left hand holds it tight to the fence and holds it down to the bed. At the first part of your cut, depending on the speed that you're feeding it in and how sharp your blade is, sometimes the board wants to climb up just a little bit. That, of course, would be problematic if you allowed it to continue, or if your hand was so far back that you can't counteract that. What I will do is I keep my hand right at the front of the board before the throat plate. And I plant my hand on the bed. Boom, like this. Everybody see that? How that works there? I use my middle finger to push in towards the fence, and my thumb and forefinger to hold that front end down. And what I do is I feed forward and then bring my hand back. So I don't run it like this. Oh no, there's my finger. And I don't slide it. That is a recipe for really bad splinters. Me going like this, I'm sliding it past. This board, probably not gonna do that to me. Practically any other board in here, oh yeah. I'm gonna have so many splinters in my hand, it's gonna suck so hard. Don't do it. All right, so, looks like this. Come to the machine, do the thing, get myself situated, sliding past me, you see, I'm not in front of it. And I start to feed it in. When my hands get perfectly parallel to each other, right at the front here, I take my left hand away. See that? They're right there, there's my mark. And I grab the side of the bed. This is important. Grab the side of the bed here. And then finish out your cut, pushing past the blade. The reason that I do this is twofold. One is it's a throwback from when we had slippery floors. The idea was that if I needed to, I could push myself away or do whatever I needed to because I had an anchor point here. So there's a safety concern there. Secondly, this is a fixed distance. I know where my blade is when my arm is here because I have this reference now. And you're gonna build up a ton of body memory doing this. So, that is why I get you started doing it like this right off the bat. It's like, okay, I know where that blade is. Boom. Every time, because this is always the same distance. So, again, if I were coming to this cut, come up to it, get myself situated, feeding through, hands get parallel, left hand away, right hand finishes the cut. When you are past the blade, you are fine. You don't have to be all the way past the riving knife, and you certainly don't have to be as far as you can reach. You just have to be past the blade. A good visual indicator on this one here is the black section of the throat plate. If you hit the black section of the throat plate, you're in the clear. That, of course, is going to depend a little bit depending on how high your blade is, but for the most part, it's going to be fine, unless your blade is all the way up. And I think even then, it's still good. Anyway, so forward, hands even, hand away, past. And then when you take your hand away, you either need to lift up like this or rotate around. What you don't want to do is pull your hand straight back or cross your hand over the bed. I think everyone can see why that would be the case. This is where accidents will happen on table saws. Sometimes people just get lazy, or they get distracted, or they get bumped into. Like, if you're in the middle of a cut and someone bumps you, or if you're at the end of the cut and someone bumps you, yeah. I think you all have figured out by this point, but I'll reiterate at this point, you never want to bug somebody when they're cutting. You don't walk up to them, you don't do whatever. If you need their attention, you wait. You either wait or you wait over here so that you're in their line of sight, and when they're done with their cut, they can look up at you, right? Yeah, never approach someone mid-action here. All right, so one more time. This time I'm going to do it straight through without pausing to demonstrate so that you can see what that actually looks like, you know, as a thing. I also really like to, as I'm doing this, make sure that I'm not getting myself locked into a single position. It'll be good for you guys initially to help build muscle memory, but I'm going to force you to walk away at various points when I'm checking you out. So, you know, you'll pick up your board, you'll be like, all right, reference surface, come over, machine is running, feeding it in, I'm feeding it in. It will take about that long. If you're going too slow, it's going to burn. It's going to burn, and it's also going to increase the likelihood of it kicking back, partly because the wood will expand a little bit when you get it hot. The moisture inside there is going to start to move. Not to mention the fact that it just increases that likelihood because it's extending the time that it's in contact with the blade. But if you go too fast, you're going to know because it's going to make a sound like a cat dying. It's gonna be like, "Wah." You wanna go as quickly as the machine will let you, where it doesn't feel like you're fighting it. Pretty straightforward. Similar to the bandsaw. You guys have, started to get more comfortable with the bandsaw. You move faster through your cuts, yeah? Same thing here. The nice thing about this is that you're not trying to follow a line necessarily, so going slowly doesn't make any sense. Usually when I was seeing you guys go slow on the bandsaws, it was because you wanted to make sure that you totally tracked on that line that you had drawn out, right? There is no line. There is only the fence. So, keeping it tight to the fence is the thing. All right. Up and away. You'll notice also I'm not flinging the board away. I'm merely letting go of it. See that? So don't try to move your offcut here, or your whatever. And if there is a piece of wood that has come off, whatever your scrap is, don't reach for it. Just let it sit there. Either it's going to vibrate a little bit, or it's going to shoot back at you, but if it shoots back at you, it means it's tiny. If it's tiny, it's not going to hurt you, unless you don't have goggles on. So if your offcut just goes coming right past you like that, don't worry about it. This might actually make really crazy sounds when you're making tiny offcuts, because the piece is going to vibrate and be like, and it'll freak you out real bad. Don't worry about it, because I'm going to do that in just a second and let you all witness the majesty that is making a cut. But if it's something bigger, just let it lie. Don't reach for your cutoff, no matter what you do, okay? You also aren't going to bring your wood back around like this if the blade is still moving. I'm doing that because the blade is not moving, and because I've been doing this for 22 years. You will not be doing that. So, anyway. All right, so I'm going to set up for a cut here. I'm going to cut this to 5 inches. So I'm getting my fence set to where it needs to be. That is 5. It's going to take a very, very small amount of material. Make sure that your bed is completely free of tools, debris, any of that stuff. There should be nothing on here at all. If there's stuff sitting here, get it over to the other side. That's why there's a giant pile of crap here and not here, okay? Like all things, you want to make sure that you have suited up with your gear before you turn anything on. And one final thing. If, when you are cutting, how can I describe this best? It's not merely when you're cutting. Whenever you're using the table saw, if you have a piece of wood that is in contact with a spinning blade, and especially if it's against the fence, you never let go of it. So of course, you push it past the blade, right? And then you take your arm away. If you are making your cut and you accidentally turn off the saw, that happens a lot. For the love of God, don't let go. The blade is still spinning, and it's going to kick that board back at you, right? Or if you don't push it, like I said, all the way past the blade, same thing. It might push it back at you. It will definitely push it back at you if you let it go while you're mid-cut. So as long as your board is in contact with the blade, you have a handle on it, okay? And not the cutoff side, the side that you're controlling. All right, so I'm going to gear up, and I'm going to make this cut, and you're going to see how much debris is produced. I would close your ears if I were you, but observe mightily. that little gap that's right there right now is gonna matter in terms of making a parallel cut. This is what I'm gonna do with you guys, is you're gonna make that initial cut, you're gonna move it over 1/4 of an inch. And you're gonna start with a wider board than this to see how accurate you can be with your cutting. All right, I'm gonna do it again. Keeping my reference side against the fence. They're dead on, which is pretty great. Yay, go me. Anyway, you will all be producing little sticks like this. There's a reason why there are hundreds of them in my office right now. And it's because you all have made these over the course of the last 6 years in Tablesaw checkout. So, what do you do when this gets so narrow that your hand can't comfortably fit in there? Well, you gotta use a push stick. I have 2 different styles of push stick. Everyone seems to prefer the one, which I'm in agreement with, which is this style. I am curious where the new one that I made went though, because this looks very small and sad. But the idea is that it has a heel on the back, and you can take your piece and drive it through.
There's one here, I don't know if it looks kind of like this one there.
Yes, this is the one. Perfect. Ah, this is what it should look like when it's new. As we cut into them, they are sacrificial. Like you can cut into them, that's not a big deal. But this one is towards the end of its life. We make flat plywood so that they don't want to break on you, you know. This is what you want right here. Thank you. This is the perfect push stick. The other style is broader and has a higher handle. It's more of a, like you should grab it by the back and push. And you can see the heel on it is much wider. It's much more like something that you use on the joiner, only it's got a narrower profile, obviously. This could be used on the joiner, but it's the kind of thing, the problem with this is that you have to exert a whole lot of downward pressure this way. Yeah, the physics of this one's not that good. This one, on the other hand, ideal. So how does the push stick work? Well, for one thing, you want to make sure that it's within easy reach before you even start. In this case, I have it sitting with its handle out on the fence right here. See that? So you're like, oh, look, there it is. It comes into play when you would normally be taking your left hand away. That's the point where you pick this up. If it's a short enough board like this one is here, I could just start with it on here, but generally speaking, if you're working with something longer, that's not feasible, starting with a push stick on the backside. So you have to be prepared to pick it up mid-cut. That's what I'm going to be training you guys on here. So, just like I'm making every other grip cut, you start the same way. You're feeding through. When you get to the point where you can lock your thumb of your left hand on the back. So if you've got a broader reach, good for you. But when you can hold this board completely in place and keep it from wanting to slide backwards, thumb on the back, that is when you pick this guy up. Can everybody see that? Yeah, go ahead and gather around. If I don't have my thumb on the back, that's a problem. So, as I'm feeding it through the thing, I get to that point where I can get my thumb on the back side, but I haven't crossed over onto the throat plate yet. Boom. That's when I pick up the push stick. So, bring this guy in again for just a second. So, totally normal cut. And I realize I'm repeating myself, but repetition is the heart of learning. My 8th grade English teacher would be so proud to hear me say that. All right, I get to that point, I lock my thumb on the back to keep it from pushing backwards at me while I do this trade-off. And you do pause when you do the trade-out. You don't keep moving it forward with your left hand. There's a slight pause as you go. Pick it up. You need to put the push stick in the center, dead center of your board, or of whatever that distance is between the blade and the fence. Note taking, note taking. When I give you specifics like this, you write them down. And the reason is you're going to review your notes before you get checked out, so that I don't spend 2 hours with each of you, and instead maybe spend an hour and a half with each of you. So, when you do this, you get to that point, you hook your thumb on the back, you pick up your push stick, you put it dead center of the piece that is between the blade and the fence. And then you very slightly, and I do mean very slightly, angle the nose towards the fence. You're not pushing sideways with your push stick. You're just making it slightly easier for it to stay close to the fence as you're pushing. I also need to reapply a little bit of hot glue to this one. You'll notice that there is a very slight curve that I have put in this plane here. The idea is that it's touching here at the heel and here at the front, and when I rubberize them just a tiny bit by putting hot glue on them, they grab. It's really, I feel like a genius for having come up with that. But yeah, so boom, boom, just at that little angle there. Again, like I said, not sideways, but like that. Because then as you're pushing forward, it ends up also pushing towards the fence. The problem with this cut is usually people trying to, not trying, but this accidentally kind of rotating away. This really needs hot glue though. And so I'm gonna plug in the glue gun really quick. We'll improve it and then we'll make our cut. If you need to apply hot glue to something, whatever that thing might be, the glue gun is in the top drawer on the left in the glue room. Because frequently, of course, we need hot glue to temporarily hold things in place when you're gluing them. So one of the things you guys are going to be doing in your checkout is first you're going to cut things down with your hand, you know, get the width that you're looking for. But then after you've done that, you will reestablish a second reference side, which, you know, if that might involve either going back over to the joiner to make a not parallel, but to make a second good side, or if it's flat the way that this one is, I'm just going to call this one reference as well. And then we're going to cut this into 2 narrow, identical pieces. So because right now it's at 4.5, I am going to bring my fence down to 2. You can see that's a very thin cut right there. That is not something that I would be comfortable using my hand to do. And I definitely wouldn't be comfortable with you guys using your hand to do it. So how do I know when it's time to use the push stick? For me, it's when the cut gets narrower than the width of my hand, minus my thumb. You know, I have pretty broad hands to begin with. So, but when it comes to this, when I'm pushing my board through, I have my thumb tucked underneath usually. Or as it gets narrower, I certainly do, as I'm, you know, working with it. So as soon as this distance, right here, gets narrower than my hand, that is when I start using a push stick. Feel free to use the push stick in other situations, if it is wider than that. But you have better control with your bare hand than you do with the push stick. So, you know, there are relative benefits and deficits to each method. I'm going to double check my movement here. It appears to be getting hot-ish. Usually all I do is I like mash it into the end. Actually try to like work it into the wood. So it's not like a little ball, it's more like, I don't know, it's hard to describe. In this case, there's already quite a bit on this end, it's just like covered in sawdust, so it's not feeling like rubber anymore. So I'm just trying to melt it a little bit with that end here. I'll apply just a little bit. Cool for a second. I'll move this back over. Mia. Actually, no, that won't work. That'll be too low. Just making sure this is going to grab the way I want it to now. Oh yeah, look at that. Don't want to move at all. Woo. That's what you want. You want this bad boy to just like stay nice and tight, okay? So, like I said, it's an exact same beginning setup for every other rip cut. The difference is just trading it out, getting it in there. Now remember too, when I go to do this now, what I'm going to do is not put it in the center of the board. It's going to be in the center of this distance here, the distance from the blade to the fence. That is where it's located. It's not the end of the world if you cut through your push stick. I would rather that you not, though, if it can be avoided. All right, watch. The one that's on the fence at the front of the throat plate, thank you, is what you're using as your guide for where you don't want to have your hands anymore. It's very, very important that as you're doing this, you don't hang on to this offcut piece. You may think to yourself that you're doing a good thing, but you're not. What ends up happening is you pinch the blade if you're holding on to this, and then it kicks back. So remember, this offcut piece, you have no business touching it. You are in control of the piece that is right here, okay? All right, so we're gonna do it again because I'm trying to establish two pieces that are identical. I'm gonna go ahead, do it up like that. also why you establish a reference surface. This is my flat side.
So for that second piece, is the side that you cut off what your reference surface is for that next piece that you do?
In this case, it was, because when I had cut that initial little sliver off, the surface that I had was beautiful. What I could do is cut that first one and then take my cut off and rejoin an edge and make that my reference surface, if my piece is big enough to comfortably handle that. Or before I make those cuts at all, I go back over to the joiner and I join that edge again too, that opposite edge. So that all I have to do is flip my board over and I've got a new reference side. Make sense?
Yeah.
Yeah. Now, again, generally speaking, we wouldn't even be doing that because you're gonna subdivide your boards on the bandsaw into their smallest millable parts before you even get to this. But this is table saw practice, and therefore, we're doing it this way that doesn't make a huge amount of sense, practically speaking, if you were building something. But these are your rip cuts. Huzzah! Huzzah, rip cuts. Questions about this part of it? What time is it? Oh yeah, we're doing great. All right, when you are done with your rip cuts, you need to lower the blade back into the body of the saw and clean up around where you're working. You don't have to lock it down just the same way that you don't have to lock anything else, but, and then sweep it up. A slippery floor is an unsafe floor. It's also a fatiguing floor, frankly. And then I'll get the rest of that later. All right, questions about that aspect? Yeah? All right, moving on to cross-cutting. You're gonna go over to that table saw. Okay, cross-cutting. So this table saw is set up to also make rip cuts in the sense that it has a rip fence. You may say to yourself, but Sarah, why would anyone need to rip cut with a cross-cutting blade? Which, if you take a look here, you know, same idea. It's got the height control on the front. See my blade, how it's got all of those many teeth as opposed to the fewer ones? I didn't talk about it before, but I will now, real quick. There is another kind of common table saw blade. And frankly, you're probably gonna find that in most school shops. Again, we have the luxury of 4 table saws, and therefore we don't have to compromise, I guess. And that is this one right here. This blade is called a combination blade. And do you see how the teeth are set in ranks? They're not consistent all the way around. They, you know, there's a chunk and then a big space and then a chunk. The idea is that this tooth pattern and angle does an okay job of both rip cutting and cross cutting. Doesn't do a great job of either, frankly, but it does an okay job of each. So in most school shops where there's only 1 or 2 table saws, excuse me, 1 or 2 table saws tops, they're pretty much all outfitted with a combo blade because you can do just about anything with it. It just doesn't do it as well as either of those, you know, blades do on their specific task. Back to the rip fence on this though. Why do I have a rip fence on a machine that is set up for cross cutting? The answer is because regardless of your operation, if you're cutting plywood, you need to use that blade. Because the plywood changes direction from layer to layer, it should always be cut with a cross-cutting blade. It's going to yield a better cut. So I could be over here rip cutting plywood with a cross-cutting blade because that's the appropriate blade for that procedure if I don't have a specific blade for plywood, which I do, but you guys don't. So anyway, that's my point. So it does get used. It's all right. Works exactly the same way. Raise the thing, lock it down, yada, yada, yada. all of the fences in here work on that same concept. It's been proven to be the best possible method. Okay, so if I'm gonna crosscut, like I said, I gotta use one of two things, either a miter gauge or a sled. When I'm setting this up, make sure that the blade is all the way down, because you don't want to hit the teeth with either your sled or your miter gauge while you're getting everything established. This is a miter gauge. Whoop. Right here. This has this kind of quality to it. See that? I can change the angle. I can also change the location of the fence. I can move this over. The back side has presets on it where if I loosen the handle and then remove this screw here with the bushing in it, I can move this to set angles and get a really pretty accurate cut out of it. There's not a whole lot of play. So for example, if I wanted to do a 45-degree angle, I can set that to 45 there, tighten up my handle, and then that's going to allow me to reference side against the fence, come through and cut my board and get an angle on the end. You guys probably aren't going to need this setup though, because you're only going to be doing 90-degree cuts on the ends of your boards, unless there is something that you're doing for your cutting board that involves an angled cut, in which case we can go over that later more specifically. But in the meantime, let me see, come on baby. Just going to reset this at 0 and set it aside. The drawback of using the miter gauge over a sled is what I was mentioning before, that as you're moving this along, your board can slide across the bed here really pretty easily. The beds have been waxed to reduce friction. Sometimes I've seen people who actually put like grip tape or something equivalent to it on this surface. Kind of mucks up your blades though. It does keep your boards from wanting to slide though. So it has that going for it. For myself, I like to use a sled whenever possible. It's just, it cuts down on that variable. So this is the sled you need. This one right here. It says #1 saw only, 90-degree cuts only. The reason that it is specifically for this saw is that the miter gauge spacing and location are different on every single one of these stupid table saws. It's one of the reasons I get frustrated with their differences. Apart from the fact that this is the only one with the major safety feature on it, I can't build one sled of each kind for each saw. It's another reason why we've got them divided by type, is to reduce that aspect of things. But anyway, this, you'll see though, this says #1 saw only, 90-degree cuts only. Do not angle the blade and then expect to use this fence, or I will find you and I will kill you. Building sleds like this, believe it or not, that are accurate is more difficult than you would believe. It's a gigantic pain in the tuchus. So, yeah, you wouldn't think so, but it is an enormous pain in the ass. So please don't make it so that I have to build another one. Anyway, but the beauty of this is that the whole thing slides. So the likelihood of my work sliding as I'm cutting is significantly reduced. That's what I'm trying to say. So similar idea in terms of setting up your blade height. Try to get a little bit of height on this. Yeah, there we go. Now it can see into the sled. Haha. So, a little bit of blade. Now set the blade height, just go ahead and take your board, set it down. And then raise your blade so that, again, there's one carbide tooth height above, but not the gullet. On the cross-cutting blade, it's a little harder to do because there isn't as deep of a gullet. Just be aware that that's a thing. So my blade is in the correct position. Lock it up, or not. Frankly, the locking mechanism on this one doesn't work that great, so if you don't lock the height, it's not the end of the world. All right, so the goal of doing this now, remember, is twofold. It is to both square your ends, but it's also to make your boards a specific length. Okay? So, how do I do that? The process for doing that is this. Start by taking your boards and making sure that the ends are marked. Doesn't matter what you mark them with, but you need to be able to tell just by looking at them if you've cut the end off of it or not. And if you can't tell just by looking at it like this, you got to make sure there's something on there to cut off. Does that make sense? Yeah, so mark your ends. Doesn't have to be with anything special. I didn't even have to mark this one because it's got the writing from, you know, the inventory number and everything. But I did have to mark the other end. Just put a little scratch mark on it. Anyway, what you're going to do is you're going to start, especially if you have multiple pieces that you're trying to establish at the same length, you're going to start by squaring one end of all of your pieces. So, because I'm trying to make two that are exactly the same. Just like with the other table saw, reference surface is against the back here, and I'm going to stand to the left of the blade. So here I am, left side. I'm not directly behind it, left side. My right hand, yeah, good call. My right hand is going to be right on top here. You see how I've got my thumb at this first transition? That's a really good indicator of where you should be. Don't be right above. It's too easy to slip down. But right here, you should be good. Plus, just like with this little joiner, you remember how hard it is to adjust the fence if you're not pushing right in the center directly over that slot that it's writing on? Same idea. So with my hand right here, I can move this fence really easily. If I'm over here, it's a lot more work. Okay. And then with my left hand, I hold the work tight to the fence and down to the bed. The whole idea is that you don't want it to slide as you're cutting, right? So what I do, right on here, there's this beautiful little diagram. So gorgeous. There's these two marks and the world's crappiest drawing of a hand. And the idea is that your hand is generally in this vicinity holding everything still. I hold it like this, sometimes with my pinky finger out, so that if you can't see that, go ahead and kind of take a look. My thumb is the one doing most of the work, and that's holding down. And that seems to be the big key, is holding everything down, more than the fingers holding back in. You don't want to do this because it'll pop up. Thumb on top, fingers here. I like to have my pinky there because then I can tell if I'm moving or not. Like, again, it's an anchor point. The problem I see is people doing this way as they're going, it can slide. Pulling back, it can flip up. Pushing down, nothing happens. It just doesn't want to move. So that's the big important one. So my initial cut, I usually cut off, something over 1/4 of an inch. Not a huge amount. On your initial squaring cut, you should cut off just enough that it's going to get squared. But not so little that the blade is going to want to drift out to the outside end. Because the blade does have some flex, remember. So if I'm like just barely kissing the end of this, it's probably not going to be square because the blade's going to be like, I'm just going to ease this way. So I put just enough so that there's definitely material on both sides of the blade and it's not going to be able to pull that easily. Think about when you're making really thin cuts on the bandsaw there, right? That how the blade just wants to like move to that. It happens here too, it's just not quite so obvious. So with this one, what I'll do, I usually get myself positioned right about here. I don't start all the way at the back and start, I get it close to where the cut is gonna begin. I get myself positioned. I'm pulling it back so that I can push past the blade here. And I either go through until I can hear the cut is finished and then I pull this guy back, or, depending, I push all the way through until this stops and I let go. Remember, this saw does not have that safety on it. It's just gonna cut no matter what. Again, I get myself situated. My hands are more or less on top of each other. They're not spread way out, they're like this. And then, that kind of a thing. If I do this and I pull this away, I will be able to take this piece and check for square while the blade is winding down. Whatever you do not pull back. Because that little offcut there frequently will get jammed up in there and it'll shoot across the room. So just push it past, be patient, turn off the saw. You also have to be a lot more aggressive about turning this saw on and off. There's a switch right up in here and it's a green button and a red button. Green button is easy enough to deal with. The red button though, that off, you can't just turn it off with your leg unless you really are working. When I turn it off, what I usually do is I just grab the entire box and squeeze. Like you're trying to crush its testicles, just like that. It's the best comparison I can draw. Seriously though, you get in there and just mash it with your palm because trying to turn it off with your fingers, it's like, ow. Anyway. All right, so let me show you what this looks like. We're almost done, I promise. We're so close. Gear on up. But even worse, I'm out of square this way. One of the advanced students has been doing a lot of compound miters and cutting them on the table saw, and it looks to me like this didn't get set back at 90. This one in particular is like really hard to set back. So same thing, raise it up all the way. In this case, I don't need something to span the distance there because I've got the sled. Yep, just a tiny bit, but that tiny bit is enough. So it is worth checking this before you do any cutting or any final cutting. Another reason why we only take a little bit off on this end is that if it's still not correct, I can just keep going. So I tend to factor in a minimum of 2 extra inches in length, sometimes as much as 4 extra inches, depending on what I'm doing, so that I have that play there if I need to re-square an end. All right, that's pretty good right there. So I'm going to try it again, and I'm going to double check that there's nothing here that's throwing me off. And my reference side is against the fence. Lower my blade back to where it should be. Generally speaking, I can hear when my cut is wrong. As I'm cutting through, if it goes shring, shwing, and makes this sort of ringing sound twice, it means that it's cutting the front and the back as it's going through. And that will not be square. I can almost guarantee it. But like I said, we'll see what happens here. And I'll do it again. it's perfect now in that direction. Ah, and it's perfect in the other direction too. So now I'm going to repeat that with my other board. Square one edge. If they're going to be the exact same length, you're going to set up a stop, and you're going to do it one time. So once you set up that stop, then every board can go against it and be cut perfectly identically. This is part of that reducing variables idea. So I'm going to take one of these boards, this one right here, and measuring off of my clean end with my reference side towards me, I'm going to measure and mark how long I need this to be. So let's pretend that I need two 10-inch pieces. Or, we'll make it 11. For this, I just use a tape measure on the top, and I make a very small mark. This is one of the reasons why I have to use mechanical pencils. Like, you can actually add length or take length away when you're doing your marking if you haven't, if you don't have a thin enough pencil lead to work with. So I've made this tiny mark right on top there. Like, it's very difficult to see, right? Then, with your combination square, with the reference side against the reference side, flat. Flat like this. Everybody see that? What I'm going to do is I'm going to put my pencil on the mark that I just made, and then move my combo square up to it. So that now I have a line that is perfectly accurate. You'll notice I didn't go back and forth scrubbing my pencil into it to make sure that my line was like crazy. It's a thin line. Once I have that on the top, then, oh, wait for it, I flip it up, and I repeat, and I put it on this edge here. So now I have a line that is absolutely gorgeous on the top and on the front face. I only need to do this on one of my boards, because once I get this set, there's going to be a stop in place, and I just have to make sure that I've got my reference side and my clean cut side against my blocks as I go, right? So don't do this on every single one of your pieces. You're going to do it on one. Set it up, and then make your cuts. So, what does that look like? Again, reference side against the fence, clean cut side off here. This should be the end that I'm cutting off, confirmed by the scribbles that are on it. I move my sled way far forward so that what I can do is I can look at the blade straight down here and make sure that it's actually in line with my line. I want to pick one of the teeth that is angled towards the line, right? And that's the one that I'm going to choose to line everything up with. So, right there. If any of you guys want to kind of look straight down on that, you're welcome to see how I've got that set. The blade is on the waist side. But that board or the tooth is angled right onto that line, and it's just like, it's just right there. For the benefit of the people at home, hopefully, oh yeah, you can see it, sort of. All right, here's where the magic happens. This is some fun stuff. You are going to need one clamp. There, generally speaking, will be one clamp that lives under here. And a block right here that has a little square on it. The square is the square corner. You can use just about anything as a stop block, but on the table saw, it's particularly important that it's dead square in this direction and this direction. Looks like this one has seen some better days at this point. Might need some retirement soon. But depending on the height of what you're doing, anyway, having a square block is really important. That's really what it comes down to. So, make sure that you don't have your threads extended all the way. You've got some wiggle room in the head here. Here's how I do this. Watch, it's magic. Here's my square. The square goes against the end of the board. So I move this forward until it's where it needs to be, and I hold on to it using my thumb right there. Take this guy, set it down, and slide it up to my board, and then I pinch it in place. Then I can pick this guy up, set it right down, set the bar right down on top, move the head in, tighten it. And then I double check. Perfect. I will do it again. I will demonstrate that magic one more time, because I move it up, I get it where it wants to be, I kind of lock it against that tooth. Just by tapping it forward. Hold it in place, pick this guy up, slide it forward, pinch. The problem is when people continue to push after they slide it up. They're like, gosh, I fucked it up. It's like, well, yeah, don't push it, pinch it. Push, pinch. Pick up, drop straight down, move the head in, tighten, and there it is. Ta-da! Yay! All right, so now when I go to make this cut, now what I have is a board that is actually going to be tracked on 3 sides. Think about it. I have a stop, and I have the back plate, and I have the blade. So that as I'm cutting this, if I were to let go of this piece too soon, or if it were not clear of the blade at the end of my cut, it could get caught. So what I'm going to do is, in this case, I am going to hold this piece, and I'm going to pull slightly back against my stop, and I'm going to hold it back against here, and I'm going to push this sled all the way through until it stops. And then I'm going to pull my body away, turn off the saw, and wait for the blade to stop before I reach for anything. If I didn't, otherwise this little dude might just be like, ah, and fly back at me, or, you know, bend the blade. That's happened. That's always fun. So observe how this is done. Make sure that there's no debris. Slide it up. Do it again. Material that moves. They are exactly the same length. They are more or less the same thickness. But this is how you create parts that are repeatable. This is how you make things that are the same as one another. If I were building a table right now and these were aprons that would have to be opposite one another, they would need to be exactly the same. You know? So there it is. Questions about that? When you are done doing this step, you need to break everything down. Take the stop off. Lower the blade all the way into the bed. Take the sled back off the table. It is heavy, don't be surprised. And then these little dudes can just go in the burnables, and there it is. And that, my friends, is how you use the table saw. Ta-da. What we are going to do, we're not going to do anything for the rest of class, unless you want to talk to me about your designs, which I'm happy to do. And there's not much class left anyway. But I am going to, starting tomorrow, have sign-up slots to teach this to you guys individually. In order for you to get checked out on the table saw, I need you to prep a 14-inch wide piece of wood that is at least 6 inches wide. It can be wider, but it got to be 14, got to be at least 6. And I want you to mill it, preferably over the course of 2 millings, but not necessarily, depending on what you're going to do here, to an even increment. And I want that even increment to be extremely specific for you. So 7/8, make it perfectly 7/8. 3/4, make it perfectly 3/4. I want you to try to get something as controlled as you can. Because this is about accuracy at this point, right? I'm trying to be accurate. So these are my 7/8 inch pieces of wood. If you only have time for 1 milling, maybe try 7/8. However, if you are able to come in today and do your first milling, get your stuff, do your first milling, and then tomorrow do a second milling before we get started, we should be able to do that. I will have slots, sign-up slots for the weekend, because the sooner we get this done, the sooner you guys can do your thing. They will be 1.5-hour slots per person, and certainly if there are things that you need to practice on, we can always do it again too, okay? I will have probably 4 slots tomorrow, and I'll do, I guess, 3 on Saturday, 3 on Sunday. If you can't make those, that's okay, we can do them on Monday, but let's try to get it as banged out as possible, okay? Yeah.
Can you repeat the dimensions of the board that we need?
14 long, at least 14 long. It could be longer. At least 6 wide, preferably no wider than 8, preferably